5 days until Christmas. The PPU's major functions were in place, backgrounds and sprites. I shifted focus from the headless front end to an interactive one. I already had a shell of an SDL2 project. Draw one ball on the screen, draw a box with the mouse, and upscale the result with a mix of nearest neighbor and bilinear. How long would it take to drop in my emulator core? First I replaced the ball with a dynamic texture. Because SDL and a PPM writer need different color formats, I moved the palette out of the machine structure. I removed most of the breakpoint code, seeing as the player can close the program at any time. I filled the dynamic texture with the emulated frame buffer. It was wanting command line arguments and I was impatient, so I briefly hard-coded the ROM file name. And it crashed. I needed to fix the palette loader. The problem was the wrong OR operator. After that, I ended up with the PPU's output in a window. To move the cursor, I needed to add controller reading. An NES game reads the controllers one bit at a time. It sends a strobe pulse to make the controller's chips sample the buttons, followed by 8 clock pulses, one to shift out each button. At first, it accepted only keyboard input with hard-coded scan codes. It's better to use scan codes than letter codes for game input. Scan codes don't change when French and German keyboards move Z around, or Z if you're British. I was interacting with my emulator for the first time. Horizontal sprite flipping also worked the first time. But what's my frame rate? I'll ask Stack Overflow. I took a shortcut and had it run at 1 frame per 17 milliseconds, which is slightly less than 60 frames a second. That should be close enough until I start making sound. It was enough to play Thwaite, a missile defense cute-em-up. Gotta keep the villagers safe. "4 days until Christmas. Sound is not as urgent as mappers. A mapper is a circuit that lets the CPU and PPU see more memory. Most games from 1987 and later use a mapper. So do most of the more comprehensive test ROMs. But even before that, sprites at edges of the screen have problems. I started Thwaite. Good news? The camera pan was working. Bad news, I saw garbage at the very top and the far right. It looked like I was writing some rather sloppy code. Fortunately, I caught myself. I had it disregard pixels of sprites outside the screen by loading 0 instead of the pattern. Occasionally, SDL2 takes about 15 seconds to start, during which it freezes my whole XFCE session. Once the most egregious sprite problems appeared fixed, I began to add support for larger ROM images. Most popular mappers are defined only for ROM sizes that are a power of 2. For example, Mega Man 3 is 256K of program and 128K of character, both powers of 2. Mappers have a small amount of memory inside a chip to control which banks are selected to be visible to the CPU and PPU. And again, I needed to clear that state at power-up. Memory cost a lot of money back then. The flip-flops in mappers needed to be particularly fast because they added to the time needed to form a complete address. Memory limits controlled how small of a block a mapper could map. This was usually no finer than 8K on the CPU and 1K on the PPU. Many mappers have a fixed bank for the CPU that can't be mapped out. Game Store commonly use subroutines here. It also holds the interrupt handlers, which must always be present. Because the 6502's interrupt vectors are at the top of address space, this fixed bank usually corresponds to the last bytes of program ROM. Ran nest test again to make sure I didn't mess anything up. Then back to the headless front end. Some mappers can change the nametable arrangement. This way some scenes can be left and right and others top and bottom. Rare preferred a mapper with 2 completely separate screens, one for the playfield and one for the status bar. And the mapper changes messed up the title screen. What happened? Of course, it's mapping everything to 0. "3 days until Christmas. I needed to operate certain ROM's title screens to get in-game, so I built a way to take a button on the command line and then press it 2 seconds after power-up. I wanted to make button names case-insensitive, but C lacks a case-insensitive string comparison function. POSIX, the API of Unix systems, has such a comparison function. That's fine for GNU/Linux and BSD systems, but not on Windows. So I had to write my own. That way, when the user gives a button name on the command line, the parser can compare it to all known button names and find a match, regardless of uppercase or lowercase letters. It turned out most familiar error numbers were also defined by POSIX. We can't ship Steam Decks out to everyone in the audience. I realized it'd be more convenient to give a number of frames to run. If I see title screens, then the start press went through. Now back to the SDL front end. Adding a command line would make it useful with more than one ROM. I chose what options I wanted to offer, and changed the main program to call the command line parser. Another 15-second pause, frustrating. I had designed a mapper for the Action 53 multicart in 2012. It needed to support all discrete logic mappers used by entries to a game jam, the first NESDev compo. Because I didn't know Verilog, I wrote a spec and a comprehensive test ROM with both interactive and automated test modes. Others turned the mapper into working cartridge hardware. I designed a structure to represent mappers. Most mappers switch in pages on writes to special addresses. It's common for these to be in the top half of address space so that reads can come from ROM and writes can go to the mapper. This structure is a bit like a V-table in C++. The INES format gives each mapper type a number from 0 to 255. I compared the mapper number from the ROM to known mappers so that I could set up the V-table and call its constructor. 2 days until Christmas. Yesterday I added a way to press buttons in the headless for an end. Today I documented it. I was calling instruction counts lines because of nesttest. It doesn't make sense for any other front end. Now on to reading the spec I wrote in 2012 for the Action 53 mapper. Alongside the spec I wrote some validation tools. One was a reference implementation of bank switching in Python. It shouldn't be that hard to translate to C. Got it compiling and added the register interface. Action 53 has both user registers and supervisor registers. Originally, the supervisor registers were for the menu's use. The mapper was meant for a multicart of a few dozen games whose program sizes range from 16K to 256K. The mode register controls how much ROM a game can quickly get to, so it doesn't accidentally switch to another game's code and crash. Some games have a 16K fixed bank and switch the other 16K. Other games switch out the whole 32K of ROM at a time. When the program switches to a different bank, calculate the effective bank for the lower and upper 16K and update the mapping used by CPU read functions. Action 53 and MMC1 use the same IDs for nametable arrangements. I made separate functions to handle writes and update the ROM map. More than one register's effects can update the ROM map. Action 53 responds to two address ranges. One selects a register to write to, the other sets its value. A few NES mappers use seek and read to put fewer pins on the chip. Action 53 uses it to remain compatible with the mappers it emulates. The games are unaware of register selection and only set values. If the mapper is already set to single screen mirroring, both user mode registers have a bit to choose which screen that is. Some of these functions that I wrote for setting mapping on Action 53 eventually became convenience functions used by several mappers. I made my first draft compile and fix the register numbers. I added some logging to get ready to try the test program. Uh-oh, blank screen. I needed more logging. This was a little better. That was a problem. The mapper wasn't seeing register writes. I got writes through, but nametable arrangement was still wrong. I had to leave fixing that for tomorrow. Christmas Eve, the last day of Advent. I'd given up on MMC3, the mapper used in many later NES games. It'd have to wait until after Christmas. Briefly operated the test manually to get a feel for what it was doing, followed by more logging. The video memory mapping code was unaware of switchable mirroring. I had to rewrite it. Later mappers watched the PPU read video memory. That's how they tell when to interrupt the CPU to change scrolling. Some early emulators made all video memory writable. That caused B-Wings and Landmaster to overwrite their character data. I prevented that by returning a null pointer. After I rewrote video memory mapping, the automated test worked, though I couldn't test how it reacts to pressing the reset button. All I wanted for Christmas was playing one game with a mapper. I decided to do the simplest single game mapper first, BNROM. This was used in Deadly Towers, Lizard, and Haunted Halloween 85. It switches all 32K of program ROM and nothing else. The earliest mappers have bus conflicts. They aren't sophisticated enough to hide writes from the ROM chip. When the game writes a value to the mapper and the written value doesn't match the value in ROM at that address, the CPU and the ROM fight over what voltage goes on the data bus. I emulated the CPU as always winning the fight. BNTest is a ROM I made shortly before developing Action 53. It tests whether a ROM bigger than 128K works. Deadly Towers is the largest licensed BNROM game at 128K. Lizard and Haunted are 4 times that at 512K. It looked like something was wrong with the character RAM. Logging the PPU mapping, logging video memory writes. Those nametable mappings looked suspicious. This looked a little better, and I had BNROM and Action 53 using some of the same functions. I tried 240p Test Suite and Haunted for the first time, and unfortunately, 8 by 16 pixel sprites were broken. This was on my mind all over Christmas.